Okay, good morning everyone. Today we'll be moving on to section 8.6. We're skipping a section. We may come back to it if we have time, but we want to get to section 8.6, radical expressions and rational exponents. Today I'm looking at just radical expressions, although we'll touch very briefly on exponents, and then in a couple of days you will be able to quite freely go from a radical expression to a rational exponent expression and vice versa. But today we'll just be working with radical expressions. Okay, so a couple of some terminology here. What's a radical? Well, you're used to looking at it as the square root symbol. Okay, so the radical looks like that square root symbol. Right? And then an exponent is always the number that a power or base is raised to. So here I have 2 squared. So 2 would be the exponent and 4 to the third. 3 would be the exponent. 2 squared would be a power. We would consider 2 the base and 2 the exponent. And 4 to the third would be a power as well. 4 would be the base and 3 would be the exponent. So today we'll be working with radicals and exponents. Okay, as you're used to seeing the square root radical, we say that it has an index of 2, which I put in there. It has an index of 2, but we generally don't write the index 2 when we talk about square roots. It's assumed that if we don't have an index, we're talking about the square root. And then we have the third root radical. We have the index 3. And then the fourth root. Okay, index 4. So we have the square root, third root, fourth root, and then we have the nth root. Okay. So what does it mean to take the nth root of something? Well, basically it means to, we'll see here what it means. If I were to say what's the square root of 4, what we're really asking is what number multiplied by itself 2 times, because the index is 2. What number multiplied by itself 2 times gives you 4? Well, that's equal to 2. And then likewise, if I said, what's the cube root of 8? Okay, the cube root of 8. So I'm really asking what number multiplied by itself 3 times. 3 is the index. So what number multiplied by itself 3 times will give you 8? Well, again, that would equal 2. Because 2 times 2 times 2 is 8. 2 to the third is 8. Okay, so that's what we mean by the nth root of something. So what number multiplied by itself n times gives you the radicand, or the number underneath the radical. All right, and so here, so this is going to be very important for you to commit to memory if you haven't already, if you don't know your multiplication facts, or multiplication facts related to powers. Here I listed a column or a table. I have n, so n goes anywhere from 1, 2, 3, 4, 5. And then n squared, n to the third, n to the fourth, and n to the fifth. So 1 squared is 1, 1 to the third is 1, and 1 to the fourth is 1, and yada yada. 2 to the squared is 4, 2 to the third is 8, and 2 to the fourth is 16, and 2 to the fifth is 32, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81, and 3 to the fifth is 243. Okay, 4 squared is 16, 4 to the third is 64, and 4 to the fourth is 256, and 5 squared is 25, 5 to the third is 125, and 5 to the fourth is 625. So 5 multiplied by itself 4 times gives you 625. Okay, so that's working with powers. Now, in working with roots, if I ask what's the square root of 1, so you're asking yourself what number multiplied by itself 2 times, multiplied by itself twice gives you 1. Well, the square root of 1 is 1. The cube root of 1 is 1, and the fourth root of 1 is 1. The square root of 4 is 2, because 2 multiplied by itself twice gives you 4. The cube root of 8 is 2, and the fourth root of 16 is 2. Because 2 to the fourth, or 2 times 2 times 2 times 2 is 16. Cube root of 9 is 3. The square root of 9 is 3. The cube root of 27 is 3. And the fourth root of 81 is 3. And then the square root of 16 is 4. The cube root of 64 is 4. And then the fourth root of 256 is 4. Square root of 25 is 5. The cube root of 125 is 5. And the fourth root of 625 is 5. So it's going to be very important as we work ahead that you firmly are able and very freely to go from powers to nth roots, back and forth, back and forth, back and forth. Yes, it is simple multiplication, but having that firmly committed in memory is essential to being able to work with the things that we're going to work with very efficiently. You know, it's so much of math boils down to that simple multiplication of numbers. All right, so now let's continue on. So the radicand, and I think I just mentioned this, but the radicand is the number underneath the radical. So if I had the square root of 4, well, 4 would be considered the radicand. If I had the cube root of 8, 8 would be considered the radicand. Here's an important point. In the real number system, and when we talk about the real number system, we're not talking about imaginary numbers, just the real number system. Even roots, 2, 4, 6, 8, 10, 12. Okay, even roots, a square root. I mean, now that would be the cube. That would not be even. That would be odd. The fourth root, the sixth root, the eighth root, the sixth root, the eighth root. The eighth root can only have positive radicands since any number raised to an even exponent is positive. So the radicand here can only be positive. Can't be negative. For even roots, the radicand can only be positive. Only. Okay, because any number raised to an even exponent is positive. Okay, any number. All right, so for example, if I had negative 2, if I raise that to the second, well, that's negative 2 times negative 2. That's equal to 4. Okay, any number raised to an even exponent is positive. If 2 squared, well, that's 2 times 2 times 2 is equal to 4. Any number raised to an even power is positive. So the fourth root of 16 is equal to 2, since 2 times 2 times 2 times 2 is equal to 2 to the fourth is 16. So we can take the eventh root of a positive radicand. In the real number system, however, the fourth root of negative 16 does not exist, because you can't find a number multiplied by itself 4 times will give you a negative. There's no such thing. If you chose negative, if you chose like negative 2, you say, oh, well, how about negative 2? Well, multiply it by itself 4 times. You'll see you'll get 16. Why? Because a negative times a negative times a negative times a negative is a positive. Okay? And likewise, a positive times a positive times a positive times a positive is a positive. So in the real number system, you can't take the even root of a negative number. It just doesn't exist. You can't take the even root of a negative number. So the negative 16 has no real fourth root. However, some of you will say, well, what about imaginary numbers? Yes, if we take into account the complex number system, which include imaginary numbers, then that's okay. Because in the complex number system, which includes imaginary numbers, the fourth root of negative 16, it does exist. The fourth root of negative 16 would exist, okay? But we're not going, it does exist because in the complex number system, it would exist. But not in the real number system because there's no number multiplied by itself 4 times. No negative number when multiplied by itself 4 times is going to give you a negative. All right. Odd roots, however, can have negative radicands. So, for example, the cube root of negative 8 is negative 2, since negative 2 times negative 2 times negative 2 is equal to negative 2 to the third, which equals negative 8. Or the fifth root of negative 243 is equal to negative 3, since negative 3 raised to the fifth is equal to negative 253. The important points, to reiterate, odd roots can have negative radicants. Odd roots can have negative radicants. Okay? And then, oops. And even roots can only have positive radicants. Two important points. Even roots can only have positive radicants. And odd roots can have negative radicants. It could also have positive radicants because the fifth root of 243, well, that will equal 3. Or the third root of 8, oops, let me clear that up. The third root of 8, that would equal 2. So odd roots can have negative radicants as well as positive. All right, now we're going to look at properties of nth roots, and we'll just look at the product property of roots. Okay, so here they give us an example, or this is what you need to know, that the nth root of AB is equal to, we can break it up as multiplication of nth root of A times the nth root of B. So they gave us this example, the cube root of 16. Now, they broke it up into the cube root of 8 times the cube root of 2. Why did they choose 8? Because we know that I can find the cube root of 8. There is a number multiplied by itself 3 times, which gives you 8. And again, this is where it's going to be important for you to understand your multiplication facts, or that table I looked at. So the cube root of 8, the cube root of 8 is 2. Okay, very important. All right, so if I go back here, so the cube root of 8 is 2, so this would equal 2 times the cube root of 2, which is what they have there. 2 times the cube root of 2. All right, so let's look at some examples here. So let's say here I have the cube root of negative 54. Now I'm going to break it up into two products. Okay, the cube root of negative 27, and I chose negative 27 because I can, because I have an odd root, and I can take the odd root of a negative number, and then I broke it up. So into 2, negative 27 times 2 gives me negative 54. Again, we're using that property there. Well, the cube root of negative 27, that's just going to equal negative 3. And then what's left over is the cube root of 2. So there's my final answer. So that's simplified. The cube root of negative 54 is equal to negative 3 times the cube root of 2. Let's look at the next example, the cube root of negative 24. So again, I'm going to choose the largest perfect cube factor of 24. The largest perfect cube factor of 24 is 8. And then 8 times 3 gives me 24. Well, I know that the cube root of 8 is 2, so this would be 2. And that what's left over is the cube root of 3. Okay, so the cube root of 24 simplified is 2 times the cube root of 3. Now, one thing this table doesn't mention, but I like to give students is, very important, that the nth root of x raised to the n is just x. Here's an example. What happens if I have the square? What's the square root of 4? The square root of 4. Well, 4 is 2 squared. Okay, my index is 2, right? It's the square root. So, well, the square root of 4 is 2. What happens if I said, hey, what's the cube root of 8? Well, 8 is 2 to the third. 2 to the third. Well, again, that's just 2. That's just 2. So we say that the nth root of x raised to the nth is just equal to x. All right, very important point. The nth root of x raised to the nth is just equal to x. So keep that in mind. So when we take a look at the next example, what's the cube root of x to the 6th? Simplify it. Well, I'll make use of that property that I just talked about, and I'll break up x to the 6th as x to the 3rd times x to the 3rd. So I have 3 times x raised to the 3rd times 3 times 3, the cube root of 3x to the 3rd. Let me say that again. The cube root of x to the 3rd times the cube root of x to the 3rd. All right, now I know that the cube root of x to the 3rd is just x. And the cube root of x to the third is just x, and so x times x is x squared. How about the next example? The fourth root of x to the 10th. Well, again, okay, I'll break it up into something that I know. Again, using that property I just mentioned. The fourth root of x raised to the fourth times the fourth root of x raised to the fourth, and then what's left over is x squared. Remember, when you multiply powers, you add the exponents. X to the fourth times x to the fourth times x to the squared is x to the 10th. Well, but the fourth root of x to the fourth, that's just x. The fourth root of x to the fourth, that's just x. And then I have left over the fourth root of x squared. So in the end, I get x squared. X times x is x squared times the fourth root of x squared. Final answer. So that was my final answer there. Okay, so again, so this simplifies to just x squared, and that simplifies to x squared times the fourth root of x squared. And then lastly, what happens? This looks humongous, but it really isn't that difficult, as long as you remember that table that I just talked about. So here I have the fourth root of 128. Okay, so I'm going to, what is the largest perfect fourth root factor of 128 that I have? Well, it's 64. 64 times 2 gives me 128. And then x to the fifth, so I'll break that up into x to the fourth times x. So the fourth root of x to the fifth is the fourth root of x to the fourth times the fourth root of x. And then what about y to the seventh? Well, the fourth root of y to the seventh, I'll break that up. Fourth root of y to the fourth times the fourth root of y to the third. So now I'll simplify what I can. The fourth root of 64, that's just 4. Times the fourth root of 2. The fourth root of x to the fourth, that's just x times the fourth root of x. And then the fourth root of y to the fourth, that's just y times the fourth root of y to the third. So now let's see here, what can I multiply together? Everything outside the radicals, right? So there, 4 times x times y, that would be 4xy. And then I can multiply my radicals. So 2 times x times y to the third. So that's going to be the fourth root of 2xy to the third. And there we have it. So this simplifies to, so the fourth root of 128, x to the fifth, y to the seventh, simplifies to 4xy, the fourth root of 2xy to the third. All right, so what's important in this lesson? I'll just reiterate. 1 is this property here, particularly when you're working with variables. That property. And then, let me clear that up. So that property is very important. And then this table, I can't overemphasize enough, this table here, knowing how to go back and forth and back and forth and back and forth. All right, so your homework then, let's take a look at what you have to do. All right. So as you're doing your homework, go back over the lesson, look at the examples here. So I want you to simplify those 10. So write them on a separate sheet of paper and then submit it. Number 1, the square root of 75x squared. Number 2, the cube root of 64x to the 6th. Number 3, the cube root of negative 54x to the 9th. Number 4, the fifth root of negative 32. Number 5, the fourth root of 81x to the 6th. Number 6, the cube root of x to the 5th. Number 7, the cube root of negative 16x to the 8th. Number 8, the cube root of 64x to the 7th. Number 9, the cube root of 54x to the 5th, y to the 3rd. And then number 10, the square root of 50x to the 7th, y to the 8th. So simplify that, show your work, and submit it on Schoology.